Hi, everyone. Today, my guest is David Smith, or Dave. Dave is a Scala developer for a long time. He worked for many companies, including ITV, where he was a principal engineer and eventually director of engineering. Over there, they built a fantastic platform used by millions of people in the UK. Today, I would like to talk with Dave about his passion for game development in Scala. So please welcome Dave. Dave, so I'm really happy to have you here. One thing I've read in your bio that I found it quite funny is that you said that you became a Scala developer, a backend developer, by mistake or by accident. So how did it happen?
Yeah. Um, yeah, they tricked me. I've been building rendering pipelines for years. It was like the reason it isn't an accident that I built this game engine. It's something I've been doing on and off for as long as I've been a programmer.
What's a rendering
And
pipeline? I'm just
so it's anything that sort of takes some data and turns it into something visual or something
okay.
graphical,
Yeah.
right? And the company I was working for at the time, I was a Flash developer building a design application in Flash. Right, it was a great big monolithic quarter of a million lines of code, design tool. And they said, look, we have to modernize because Flash is dying, and we're gonna switch to HTML5. And this was like before sort of a site generator, static site generators were really a big thing.
Uh-huh.
So they said we need to build it's a static site generator. We need to build a something which takes some data and renders it into HTML. And we don't know anybody who's done rendering pipelines. So we're building a small team. Do you want to be on the team? By the way, it's going to be in this funny language called Scala because that was the language that our then deputy CTO picked when he fell out of bed one morning.
I see.
And so I was taught Scala by two other guys who were one of them was a Ruby guy, and the other guy was a Java guy, and they were senior to me because they were two chapters ahead of me in the how to program in Scala book. But
So
but also
they were both learning, like they didn't have any experience in Scala.
so they'd done a lot more backend services and they'd done a lot more Java type stuff than me. So they were more senior definitely in terms of the domain and stuff like that. But yeah, so we ended up building this rendering pipeline, and I've been stuck in Scala ever since. The the good news is I really liked it. The bad news is they don't do much graphics in Scala.
No,
So
that's true.
yeah, so after a while I started kind of missing the front end stuff, and I started looking around for, how do functional programmers build pretty things? I don't know. Let's find out.
Yeah, one thing
That's
I've
how
been
all this
always
started.
curious in Scala is that there is no like really plotting libraries that I know of. Like I don't
Yeah,
know why it doesn't exist, or it is that it's not really well known.
I don't know. I mean, considering we do all this data stuff, big data. Python has really stolen our thunder there. That we could have beaten them to it with a nice plotting library, but
Yeah,
yeah, we're
probably.
missing that.
And so you're already into game development. Is it something that you were doing before you were introduced to Scala, or is it something that relatively more recent interest of you?
Um, no, no. So I've always liked games, but my I didn't study computer science. I went to art school and I studied multimedia graphics. And I ended up at this company building my first proper job, building educational software. And it
Mhm.
was games and tools for kids where they were learning, science and whatever. And we did a bit of like a Conway's Game of Life type of a thing with humors and eagles and stuff like that on the little isometric grid. And we did, loads of little things like this and little games. But I really I really enjoyed the whole sort of, programming games is just fun. Like, even if you don't like making games, even if you don't like playing games, sorry, making them is great fun because you get to do all of that kind of weird, all those weird questions you get during interviews, right? That's
Mhm.
where they live in reality. They're all game development questions,
Nice.
FizzBuzz and all of that. But it's so yeah, and I kind of even though I switched to the back end at some point, I didn't want to. I never lost touch with that. I'm intrinsically motivated. I get out of bed in the morning and I'm like, what if I build a rendering engine that works this way this time? That kind of thing.
And so what
Yeah,
motivated you to use Scala for, building games? Because I mean, I understand that, you have this interest with building
yeah.
games and, you like Scala, which, kind of makes sense, but it's not Scala may not be the language that people think first when you think about making games, right?
No, yeah. So as I mentioned, I got into Scala and I got bitten by the functional bug. And I thought, oh, this is cool, right? Um, and the Flash monolith I mentioned earlier, that was object oriented, right? And there was lots of we tried Flash. Flash was a very experimental. The time when I was being a Flash developer, it was a very experimental period for everybody, and we tried like every front end design pattern you can think of, right, to try and work out the nicest way um, to send events and to manage your state and understand the
Mhm.
application life cycle that's going on. And it was always terrible. It didn't matter what we did; it was always terrible. Um, with functional programming, I was looking at it and I was very bitten by the whole referential transparency, pure
Mhm.
functions, immutable data. Oh, this could be good. How do functional programmers do GUIs? Turns out they
Yeah.
don't really. The thing that everybody ends up talking about is functional reactive programming, right? And
Okay.
that's the FRP is the big thing, right? And there was a library. I think the original paper came out of Microsoft in 1996. It was called FRAN, Functional Reactive Animation. Um, and from there, eventually, a guy called Evan Czaplicki turned up, and he made this language called Elm. And I was looking at two things. Elm, I discovered because I was looking at it thinking, oh, I understand this. This makes sense to me. And prior to that, I've been looking at Yamper, which is a Haskell-based game engine. Um, and Yamper is very complicated. I was struggling
Yeah.
with that. But Elm just sort of clicked. I just sort of understood it. I knew what was going on there.
Yeah, you feel
Um,
you don't need like a category theory PhD to understand it.
Yeah, they studiously avoid all of the fancy terms
Okay,
because
that's
they're
good.
really targeting JavaScript developers. But no, the problem I had there was I was like, well, I've really got into Scala, and Scala is I didn't I tried for many years to love Elm, but I kind of struggled with the restrictive nature of it. It's very designed for a certain target audience and for compile time guarantees and stuff, which I don't care about. And I really wanted to use Scala and functional programming to do this kind of thing, and so I ended up building Indigo, which is the game engine based on the Elm architecture, and Tyrion, which it originally came out of the Scala Center, and I adopted it, and is Elm for Scala.js basically because I think it's
Yeah.
the winning architecture in my opinion. It's the best one there is.
Cool. And so how do you find like generally using functional programming and concept to build games? Because, as you said, like it may not be like the best fit, but does it actually work? Or is it something like, like there is this book from functional programming pearls or functional programming data structures where turns out that potentially you can have the same efficient algorithm using functional programming, but it's not the standard like technique. It's not what we see most of the time. So do you find
Yeah,
that it
yeah.
actually works or is it like,
It does, and I think it's really important to understand that like I'm not an academic, right?
yeah.
I think of myself as like a mechanic or like a
Mhm.
janitor. I just plug things together and make them work. And the thing that appealed to me about functional programming was the elegance, composability, and simplicity of it. Right?
Yeah.
You very quickly in OO land, I find you very quickly end up in spaghetti with big systems. And I really like the cleanliness of the Elm architecture because it's just a blob of data and a bunch of pure functions that manipulate that data. That's it, right? So, does that work for games? Well, there's two things to talk about there. One is performance, and the other one is architectural hygiene, right? From an
Mhm.
architecture perspective, it works great, right? If you've got a purely functional set of APIs, when all you're really doing is saying, take some data and render it into a view, which is just a straight map or a transform of some sort, right?
Mhm.
That works beautifully as long as your engine knows how to deal with that. Um, and also, following the Elm architecture, you don't have to do things like uh, typically you have a thing called a scene graph, which is a sort of tree of all the entities on your screen. And quite often, what you find yourself doing in other engines is kind of manipulating that tree graph, add a child here, remove a child there,
Yeah.
that kind of thing. You don't have any of that with the Elm architecture. You just give it the new graph and it does the magic, right? So that's really nice. Um,
So is
what
it
you
something
struggle
like,
with,
sorry, I forgot this framework
that's okay.
on the front end when you React. So is it more like React, Elm?
I'm not terribly familiar with React. So React with Redux many years ago and now with hooks is similar, I believe. Because essentially the problem with React originally was that you had, as I understand it, it was that you had nested components. Each one had their own state. So if you ripped out one component, you lost all of its state unless you held onto it and put it back in again later.
I see.
With the Elm architecture, you don't have that. You have strict separation of data and view. right? So
I see.
there's no loss.
So you don't describe how you want to change the view. You just say, okay, here is the data, render it. And if
Yeah.
there is a transition, is how does it figure it out how to go from state one to state B?
It this is where Indigo and Tyrion diverge. So in both cases, all you do is you say just build another tree, right? Now that's you are allocating objects, but generally speaking, that's actually quite cheap, right? It's only once you start getting into things like DOM manipulation that it really starts to get expensive. And in Tyrion's case, the DOM manipulation is done by a virtual DOM, which very efficiently says, "Oh, what's the actual
Yeah.
diff? What do I need to do here?" And that's the thing that does the rendering. It is not as fast as FRP systems are, right?
Mhm.
But performance there is very relative. Like, is it fast enough that nobody will notice?
Yeah.
Yes,
Okay.
right.
So
and,
it's
and
just
the
like
other
as
thing,
soon as the
mm,
rendering, if you do like many images like per seconds, essentially it's
yeah,
fine. If you rebuild it, nobody will see. Essentially, the transition is just like occurs naturally, like just by the
yeah. So
refresh
yes,
rate.
exactly. So what happens in Indigo is that you every frame you will build your scene graph, which sounds inefficient, but actually it's fine. And then the underlying engine, which is not functional programming, it's horrendous mutability and right down in the core. It's like layers of procedural OO and then exposes an FP API. Does all of the work to really efficiently only render what it has to render to show your screen, to show your
I
scene.
see.
Sorry. The other thing that I always find interesting about the performance discussion is so sorry, just to take a slight tangent.
No,
There's
no, go
kind of
ahead.
two things. Um, Technically, the main performance constraint is allocations. It's nothing else, right? How many objects we manufacture, right? And if you go and watch any of Daniel Spirick's talks on performance, it's all relevant in game design because you've got
Mhm.
16.7 milliseconds to do everything, right? And if you allocate tons of objects in that time, the GC starts to heat up and you get into trouble. So we spend a lot of time worrying about that in the engine, not so much so that at the outside you don't have to care too much.
I see.
But the main thing that I find interesting is in the performance discussion is that I really care about developer performance rather than
Yeah.
engine performance, um, and because Indigo is for building like pixel art 90s games with modern graphics, right? It's not for you know you can't build an FPS out of it very easily unless you do Wolfenstein. Um, so the thing that I really care about, so in that regard, like modern hardware can absolutely pound through anything that we can throw at it, no problem, as long as we're efficient about how we talk to the graphics card. So what I'm really interested in actually is how performant can we make the developer experience? I want friendly APIs, I want immutability, I want, to understand the logical flow of my program easily and scale it out trivially with function composition, that kind of thing. That's what I
I
care
understand. So one thing that I found, like one question I had for you was, a game engine. Actually, I don't exactly know what it is. I mean, I understand it's something to make
about.
games, but can you explain me a little bit, like what's a game engine?
Yeah, certainly. So if you imagine making a game from scratch, right? Let's just say you do it in JavaScript. Sorry, but let's just say you do it in JavaScript, right? And you just open a notepad and you start coding away, right? What you'll have to do is you'll have to implement a bunch of functionality. You'll have to understand how to read inputs from keyboards or the
Yeah.
mouse. You'll have to probably maybe do some network I/O. You'll have to explain somehow how to render this stuff. You'll need a
Mhm.
game loop which ticks over every frame because games even this is one of the places where they differ from web frameworks. Games run all the time because there's always like background animations or enemies walking around or something, even if you're not doing anything.
Yeah.
So you've got to implement all of this sort of machinery, and all that a game engine really is an abstraction of that machinery, right? To make it so that you have less problems to solve, less to think about. You can concentrate on making your game, not how you're going to make WebGL work, right? Or talk to a graphics card or any of the audio stuff, for example. Um,
So does
yeah,
it mean
does
that
that does
is it more like so is it like a set of functions like you use a bit like a toolkit, or is it more like something like you have interfaces and as long as you satisfy these interfaces, they kind of work together? Or is it something else?
it's yeah no it's more like that one. So what we do is we give you a standard interface and you say as long as you plug in these functions, right, because they're just pure functions, we'll do the rest, right?
I see.
and and what that means is and all game engines are like this. You're making trade-offs, right? So I'm trading off. I'm going to make this easy for you as a developer, right? To
Mhm.
describe what you want to do, and I will take care of the rendering, and the graph and then the audio and all that stuff. Um, And in return, you're going to have to accept that I've made some decisions
Yeah, you have to
which you
put up.
can't change. Yeah,
Yeah,
you have to put up with
yeah.
it.
You trade flexibility for easy of development and speed up.
Yeah. It's always the case when you try and make it easy for somebody. You have to make design decisions and trade off stuff.
I understand.
Does that help?
Yeah, no, definitely it makes sense. That's really what I was wondering. Cool. And so does it mean that, this game engine, because games are can be completely different, right? You can have a card games, you can have a role-playing games and FPS. So does it mean
Yeah.
like Indigo, did you have to pick up like a genre or kind of games that you were focusing on?
You don't have to pick a genre. It's a great question. You don't have to pick a genre, but you do have to accept that I made it for doing kind of 90s style pixel art games, and they're 2D, right? So
I see.
we don't do 3D. You can do, I have made a Wolfenstein like raycasting demo just to see if it works. It does
What's a
work.
Wolfenstein,
Um,
sorry?
So Wolfenstein was like the original first person shooter, but
I
it's
see.
basically you see the corridors and you can walk around and stuff, but it's a 2D game in disguise, right?
Yeah. It's a bit like
It's a soft,
yeah.
yeah.
I was gonna say
Um,
Technic 3D, but actually 3D is in the title.
yeah, but it's that kind of era, right?
Yeah.
It was the precursor to Doom.
Yeah.
So you can do that, but it's hard work. So really, it's for anything that you can do in 2D. So if you want to make a classic game like Battleships or classic arcade games, that's fine. If you want to do modern, I'm spending a lot of time doing roguelikes, that works. Anything or any game from the 90s you can think of would be okay.
Okay, so even if
Pretty
I
much.
wanted to do like a card game, let's say like a
Yep,
bridge or something like this, so you could do it with Indigo.
absolutely. Yeah,
Yeah.
definitely.
That's interesting that the interface is generic enough to do like potentially an FPS and a card games. Like
Yeah. The limitation is what style of graphics you can have.
I see.
That's what it comes down to. Because the um 3D graphics and 2D graphics work quite differently. And even though we use 3D hardware to render 2D graphics, they're a simpler space. And when I was building Indigo, I had to think very hard about ruthlessly cutting down the scope to make it manageable. And this was one of the choices I made was like, well, the only games I care about are 2D pixel art games. So if you want to use
Yeah.
my engine, that's what you got to do.
And so can you give me an idea of like the sort of game you build? Like you told me like later on you will do us a small demo, but like just to give us an idea of the things you have actually created.
The things so I have a co-conspirator who's also called David. There's two of us. It's not secretly me twice. There is actually
Yeah.
another person. But and we keep starting things, and then we what happens is we start building something. We'll get into it and go, oh, if only the engine could do this, then we'll go off and work on the engine a bit, and then we'll come back and go, let's start something else.
Yeah.
So we're not very good at finishing things. The game we're working on a game at the moment, which is a it's like a sort of sim where you sort of build things, which is kind of like a real-time simulation. The thing that I've been doing personally quite a lot is been working with in roguelikes, which are I I ended up doing this by accident as well. Somebody jumped into our Discord server and said, "Could I use Indigo to build a roguelike?" And I was like, "Sure." I don't know. Can
What's a
you really?
roguelike
I
game?
always say yes.
Just to be clear, what's a
Yeah.
roguelike game?
A roguelike is a game where you traditionally they're like ASCII, but they also do them in pixel art these days, where you kind of walk around a little dungeon and you explore and you find things and you kill monsters and eventually you die, and you always die, and when you die you go right back to the beginning. So I don't know if the roguelike community will thank me for this, but I always sort of think of it as being a bit like chess, right? Like you play the game, at some point you're beaten and you have to start again with exactly where you were. The only thing that you take with you is you're now better at playing the game,
I
right?
see.
So the next time you'll get further.
So there is no
And
end to it. Like there is no you
yeah,
can't wait.
no, and also there's no end to the development. I mean, if you look at some roguelikes, like Dwarf Fortress is a good
Yeah.
example. That's been in development for like 20 years. Right? So the developers are just building and building, building. People are just playing, and they're just fun. But
I
the
really
building
like
of them
the
is.
commit messages of Dwarf Fortress are
Oh, I
amazing.
haven't seen them. What are they?
Oh, you haven't
I
seen
haven't seen them.
like
No,
a
no, no.
fix a bear problem, or you had some kind of a fish who drowned, like a die of drowning, and they're like fix these sort of issues that are really amazing. Like I think
Yeah,
some
yeah.
people make some
When
compilation of Dwarf Fortress commit messages that are like hilarious.
Yeah, but this is what I love about it. Like, when do you get to do that at work? Right?
Yeah.
It's always SQL errors and stuff at work. But
Well, you make
when
a
do you get
video
to
game and you
say,
sell it.
I fixed the fish?
Yeah,
You know, the fish
cool.
lives. Yeah.
That's amazing. Okay, so potentially Indigo, you can build it for any kind of 2D engine, but one to get the game. But so one thing I find curious is that you mentioned that Indigo is in charge of the rendering, But so it's not only the game logic, but it's also how it's visualized.
Yeah.
Is it correct?
So yes, that's right. No. So yes and no. So you tell Indigo what you want to show. So you can
Yeah.
say, I want to use this image, these textures. You can give it shaders to do quite advanced rendering techniques if you want to. Um, but Indigo is the interface onto the graphics card, right? So it's the abstraction away from um, the dirty details of how you actually like set the addresses on the graphics card and tell it which buffers to render and how you plug in
Hmm.
all the various bits of data. So yeah, so it's giving you an abstraction to work on basically, so that you can describe you focus on what you want your game to show. Like I want a
Yeah.
graphic over here, right? And Indigo goes, okay, I'll put the graphic over there.
I see. But so it means that potentially you can make Indigo produce something like a, some kind of images on like on a, I don't know, like on an executable on your machine, or it can be something on a browser, or what is the
So
output?
yeah, so platform wise, Indigo is built entirely on Scala.js, right?
Yeah.
So you can use it for you can target just about anything as long as there is a Scala.js solution, and there is a Scala.js solution for just about everything, right? So most of later on, if when we do the demo, I'll you'll probably see Electron running, which is building a desktop app, basically a
Oh, I
desktop
see. Yeah.
application, right? But you can also use things like Cordova or more modern solutions to target mobile, or and publishing your games to GitHub pages or whatever is trivial. I have an SBT command that just does it. You know,
So could you even publish, let's say, on your phone, like if you wanted to make a
yeah,
mobile
yeah,
app?
yeah,
Yeah.
yeah. We've had. There's a guy. It's really cool when somebody turns up on Discord and sends a demo of what they've been doing. And somebody a while ago made a paint application on their tablet
Oh,
using it. So it's just like finger painting basically.
that's
But
amazing.
that was fun. Yeah.
So you mentioned Scala.js. So Tyrion, so it's a framework. Is it, you said you developed it, or is it that was made by the Scala Center, or
So
how?
there was a library called and this is the problem, Skalm. I'm not sure how you pronounce it, which
Yeah,
is
it's
why I
difficult.
changed the name. Yes. So anyway, but it was made by the Scala Center, or a couple of people in the Scala Center many years ago, and I only found it after they'd abandoned it for like 5 years, right?
Okay.
Because I really wanted to do Elm in Scala.js, and when I found it, I was like, "This is it. This is what I wanted. It's perfect. Look, I tried, downloaded it. It worked. It was great. I was so happy." And I sent them in a pull request that brought it all up to date with Scala 3 and made it work with that. And they were like, "That's great, but we don't care because we've moved on. We're really
Yeah.
pleased that you like it." And so I asked permission if I could, fork it and do what I had to do to bring it up to date. And they were like, "Yeah, please do." That was really kind of them. I really appreciate it. Um, and Tyrion, yeah, and Tyrion has kind of taken on a life of its own now. It's kind of the plan always was and probably still is at some point to kind of bring Indigo and Tyrion closer together because they solve a lot of the same problems in terms of the way that the runtime works. But Tyrion is, if you want to get into open source, Tyrion is not a bad place to start because like the runtime for Tyrion is about 100 lines of code, right? There's
Wow.
lots of peripheral code that does like DSLs for syntax and stuff like that, but the actual runtime is absolutely tiny, right? And we're also standing on the shoulders of the wonderful person who ported Snap.js, Snap DOM to Scala.js, which is the virtual DOM that we use. So we don't have to do any of that either. That's great. So there's also no JS dependencies at all. It's all Scala.js all the way down.
So Tyrion potentially is not
Mm.
necessarily only for games, right? It's more like the Elm architecture in Scala. Is it?
Well, yeah, Soterian's really for web apps of any sort, right? It
Okay.
doesn't really care. Indigo is very specifically targeted at games, and um, I made different design choices, partially because I didn't fully appreciate the Elm architecture when I was building Indigo, I think, right?
Mhm.
But also because the abstraction levels are different in Elm or any front end framework. When you start modeling your application, the model is very close to what you're actually going to show, right? Like you're going to have a list of menu items so you can render a menu, right?
Yeah, I
But in
understand.
games, the model is very different to the view. Like if you look at again, if you go and look at Doom or Wolfenstein or something, the sort of 2D first person shooter, the game is really like the mini map in the corner. It's a tiny little grid with little people moving around the grid and shooting each other, right? What you can see in front of you is just a it's just a view of that model, right? So, and
Mhm.
again, if you look at Snake, the game Snake can be modeled with like a case class with a list in it. That's basically all it is, right?
Yeah.
But when you see it, you see boxes and you see colors and you see backgrounds, and so it's a big. So Indigo has model, view model and view, whereas Elm and Tyrion they only have a model and a view, right? But that's easy to it's easy enough
Yeah.
to make those work together. It's just that they have made different decisions. There's also the other decision is um, Indigo doesn't really do very many side effects. There aren't that many side effects you need to do in a game. There's lots of
Like
networking and
if you want to
stuff,
do an
but we get
explosion or something like this, then
no. I mean, so
ah,
things like going out to the world and rendering or talking to a network or
oh yeah,
actual proper side effects like you do in the
yeah, like
background.
sending an email or something like this.
Whatever you need to do, yeah, exactly. So Tyrion does loads of that and it's really good at it. Indigo does very little of it. It's not good at it, right?
Yeah,
And again, it was a trade-off. So they are slightly different, but I hope to bring them closer together in the future.
I understand. And so you said, if I understood correctly, that both Tyrion and Indigo are built in Scala 3. Is that correct?
Yeah,
And so
yeah,
how
yeah.
was they built from scratch in Scala 3, or did you have to migrate it?
No, I built them in Scala. Tyrion was Scala Elm before Tyrion was Scala 2.
Yeah.
When I took over, I ported the whole thing to Scala 3 and dropped Scala 2 completely. Um, Indigo started many, many years ago as a Scala 2 project. When Scala 3 came along, I was kind of because a lot of the choices I make are about maintenance. Like, can I really cope with maintaining all of this stuff? Um, because it was experimental, I thought, oh, you know what, forget it. We're just going to drop Scala 2. And
Yeah.
this was like way before Scala 3 came out. We switched, we were using Scala 3. I was using Scala 3 probably a year, at least a year, maybe 2 years before it really came out. So I was finding all of the problems, right? But it was good fun. It was really good fun. And I really liked the new syntax and I liked the way it worked. And I thought, oh, we'll just drop Scala 2. And if anybody complains, it's my engine. I don't care.
I see.
Right?
But so except the bug that you probably found out because it was like a rough version, how did you find the transition from Scala 2 to Scala 3? Was it quite complex or did it take you a while to,
No,
did you have
it
big
was easy.
roadblocks?
No.
No?
Well, I think one thing is so I don't so Indigo has very few dependencies, right? It's very because
Yeah.
it's very self-contained. The Scala.js was doing a really good job of keeping up with Scala 3. So that was fabulous. Um, the I don't use in Indigo, we don't use a lot of really heavy until well, more recently, like we've started using macros and we've started using lots more sort of context implicits and stuff like that, which didn't exist back then.
Mhm.
So there was no problems transitioning with macros or any of that kind of stuff. And the only problems that I had early on were um, some libraries which hadn't moved yet. So like things like JSON libraries hadn't caught up with the new macro
I
system, so
see,
you
I
had
see.
to just do it all manually. But that was okay. Um, and then of course there was the tooling problem.
The
But
what, sorry?
I there was the tooling problem.
Ah, yeah.
But I come from the days of Scala, as I said, when I first started learning it, like that was back when you had to type gen idea into SBT every
Yeah, I
time you
remember
changed your
that.
dependency. So I was used to a certain amount of nonsense.
Yeah.
And I was quite happy to switch to something with very little IDE support early on to get faster compile times and better functionality and stuff like that. So I've had a really good time with Scala 3.
So
But
do you notice some
yeah.
performance improvement in terms of compile time between Scala 2 and Scala 3?
Yeah, no, I did. I noticed it was much better. I think what's been interesting is going because I was in management for quite a while, going back into full-time development. Um, when you bring in libraries that like cats, which are very implicit heavy, the
Hmm.
compile times then they really begin to suffer.
Hmm.
In Indigo, you don't really have a lot of that, so we're getting really good performance, and the compile times are, I'm like I don't even know what people are talking about. This is great, right? It's a
Yes.
couple of seconds max. Um, so we wait longer for like npm to start than the compile to finish. But yeah, so I think it's been really good. I think it's a question of what libraries you're using and what burden they're placing on the
Yeah, for sure.
compiler.
Implicit search, generally like creating like a generating type classes, this sort of stuff, like
Yeah,
implicit
especially when you get like the
derivations.
heavy functional composition going on, pulling in functors and applicatives and all that stuff. It starts to take its toll.
I see. And so both for Indigo and for Tyrion, do you use any, so you said you don't use many external libraries, so you probably don't use cats or like Zio or this sort of stuff. Like it's mostly this. So what are the
Yeah.
dependencies? It's a Scala standard library,
So
some
yeah,
JSON.
so yeah. So Indigo really only has dependencies on Scala.js. But Tyrion does depend on cat's effect.
I see.
I was convinced to do the move because it is a lot more side effect heavy.
Oh, yeah, okay, makes sense.
Um,
So you mentioned that in Scala 3, you noticed some compile time improvement, right? When you move from
yeah.
Scala 2 to Scala 3. So are there any other Scala 3 features that you found that were helping you in develop either projects or games?
Um, I actually really love, I just generally love the syntax improvements. So switching to enums, switching to and having extension methods available are fantastic. One thing that I think I really would have struggled to do previously, I'm sure there was a way, but you know, that I would have struggled to do before. We have a DSL for timeline animations, which is basically it's a way of saying so there's like fundamental primitives for animation inside Indigo, which are to do with signal functions, which are basically functions which, given a time, they produce a deterministic value, right? And you can combine them using sorry, signals and signal functions. You can combine them, compose them using signal functions. This is signals. But they form the bedrock of the animation system, which is timeline animations, which allow you to basically say, oh, I want to move this thing from this place on the screen over to there, and then I want you to wait a minute, and then I want you to go down here, and then I want you to just keep showing the last frame because I need to stay on the screen, right? Things like
Mhm.
that. And the way the DSL works is it uses context functions,
Oh, I
which
see.
are basically where it passes the implicit time
Okay.
through all the function signatures so that you don't have to think about that while you're trying to compose your animation, which was really, really helpful.
I
Yeah,
can
sorry.
imagine it. I read about this feature, but I haven't used it myself, but it does look very helpful.
It's for that particular use case where you're building that kind of DSL. It's beautiful. Yeah, and so I think Scala 3 generally is a great upgrade.
Awesome. And also I had a question about Scala.js because this is something I haven't used really personally, but everyone I
Mm.
talked to who did, they found it amazing. They really have great things to say about it.
Yeah,
But
yeah.
one thing surprising is that I haven't found many jobs that use it, like any job advertisement. So I don't know, maybe I miss them. It's difficult to have like a clear picture
Yeah.
about what's in the real world. But do you think it's true that it's something that's more used for pet project than actually jobs? And if it is the case, do you know why?
I think there's only one company I've heard of that uses it, like seriously uses it for their front end development. And they're somewhere in the States. I can't remember the name. I think the author of Laminar might work there. But so Scala.js is amazing. It's probably I would put myself out there and say it's probably the best like language to JS transpiler around, and I'm constantly stunned at how well it works. I mean, I've been using it for years, and I'm still impressed. Right, it's amazing. There are the work is constant and ongoing, and improvements keep coming. And but it's been superb for years now.
Mhm.
I think the problem really is well, there's two problems in terms of adoption, right? One is like let's look at the community at the moment, right? The community we have at the moment, bless you all and me as well. We're all back-end developers, right?
Yeah,
So most of the community doesn't naturally like you say let's do some CSS and they go, ooh, I'm not
yeah,
sure about that, right? So we could do the Scala.js bit. Doing the CSS is more difficult. You could use it for lambdas, like AWS lambdas, using there's a library called Feral, for example, that helps you with that. But again, like when you start assessing what technology to use for an AWS Lambda, then is JS, never mind Scala.js, is JS the right language? Not
yeah.
sure compared to other alternatives. So there's a little bit of like literally having people who know how to do this who want to do it in industry. And then there is convincing industry that this is a better choice than using React when React has a billion developers, all the documentation, millions of dollars thrown at it every year, So it's an unfortunate situation where we have this absolutely spectacular piece of technology, and it really is that good, right? But actually, getting market penetration is quite tough.
Yeah, I understand. Yeah.
I'd love to see it though. I'd love to see it.
Yeah, I mean, the thing is, you're quite true about it, is that I think like among the backend developers, there is only a small fraction that actually like to do front-end stuff. So you're
Yeah,
already like when you do ever any backend language that tries to compile to
yeah,
JavaScript, you already have a smaller population
Yeah.
that are
And
interested.
if I could just quickly one more point. What's interesting, one of the things I decided to do with Indigo was you don't write any JavaScript. You don't write anything that looks like JavaScript unless you really, really want to for some reason. Like when you look at Indigo, unlike Tyrium, where occasionally it's helpful to actually drop into Scala.js being JavaScript to make some special piece of functionality work, in Indigo, you almost never do that, right? And that way, effectively, you're just writing Scala. It's just that it happens to end up running in JS or JS engine.
Awesome.
But and that's
And
how
so
and that's how good it is. You don't even notice.
in general, for people who are not familiar with Scala.js, how do you interact with a JS library in Scala? So how, let's say, I want to use, there is this JavaScript library that I would like to use. It does exactly what I want. How do you
Yeah.
interact with this?
Um, well, basically, you can just import them. So there's two ways to do this. I haven't done this for a while because I don't do a lot of it. But essentially, Scala.js has imports that just let you pull in the library and basically treat them like native objects. And you can write facade traits that basically expose the API of that library. And there is another tool called scalably typed, which basically tries to generate those for you based on TypeScript definitions, right? So it's
Mhm.
actually the interop is really good. Like it's really simple. And building your own interfaces is an awful lot easier than it sounds.
Yeah.
I just do it. I don't even use Scalably types anymore. I just do it by hand because
And
it's
I
really
guess
fast.
I imagine already many people wrote these facade libraries toward like popular JavaScript libraries, right?
Well, I think the Scalably type community have just like ported everything as far as I can tell. So there's a very high chance that your library of choice already has a facade out there to use. It's great.
Awesome. Now, coming back to the game development, so like generally, for whatever things you're building, generally, like the choice of language is determined not only by the quality of the language but also the ecosystem. So the thing is that I guess in Scala, the ecosystem for game development is fairly limited. So are there any other
Yes.
libraries than the one you maintain, or are there other people who do stuff in game development that you know of?
There's a couple of people who've made a few attempts at this. I think I don't keep track. One of them was there was the Scala game library years ago, which was quite inspiring, and that's good. There is another engine which basically specializes in ASCII art development, but I don't know whether they've carried on or not. Like because
Mhm.
I don't really keep track. The only one which I know of really is the one that I look after, and that's very actively developed, and used every day. um, the most people who look at Scala and think, oh, I want to write a game, they end up looking not very far and they end up in Scala FX or using a library called libgdx, or there's another one called LWJGL. And these are like the Java solutions to pretty much, Java-like solutions. But that didn't really, I didn't really want to do that. I have looked at all of those things, but I didn't really want to do that because it didn't give me that functional niceness, that I'm really after.
No,
So
I
it's
understand.
definitely possible, and there is an ecosystem as long as you don't mind doing Java stuff. But if not, come to me. I'm here to help.
Yeah, but talking about this, so let's say, I want to, I have some ideas of a game I want to develop. Maybe I want to
Yeah.
port an old game that I played when I was a child. And how do I start? Like, what's the entry point? Like, let's say, to Indigo and Tyrion.
Um, so first of all, you have to decide what kind of game it is. Sometimes does make sense to do it like a web app, in which case you want Tyrion, right?
Okay.
And if you want something that feels more like a normal video game, then Indigo is what probably where you want to be. You can run Indigo inside Tyrion, which is interesting. Um, but if you want help, basically there is a small Discord server that we run, which is very sort of active, and there's a link on all of the repos and websites and stuff,
Yeah, and I will
which is
probably add all the links below this
yeah,
video.
cool. There's quite a few people who will randomly chip in and sort of say, "Oh, you could try doing this." Um, um, Otherwise, we have pretty good docs. I'm always around if somebody wants to ask questions. I'm happy to help anybody. Sometimes I end up helping them by writing entire libraries. So because I'm keen on helping people get moving, so we can get a bit of momentum going with people who are building games.
Awesome. That's very nice of you. And so I know that maintaining libraries is very time consuming. And do you need help for maintaining some of these libraries? And if you do, what sort of
Yeah.
because the thing is that many people say, okay, I want to do some open source development, but you require someone maybe like who do this over a long period of time, or what kind of, if you're looking for help, what kind of help are you looking for?
I'm open for everything. I mean, I the people who so I do the sort of main ongoing maintenance of Indigo and Tyrion. But there are people. What people generally do is they turn up, they drop in, they find a feature that they care about, and they work on that,
Hmm,
and then they leave again because they're off building their game, right?
of
So
course, yeah.
it's usually something like, oh, I've discovered that your pointer support doesn't quite work the way I want it to, and they come in and they fix it, and I go, thanks, and that's great, you know. So I'm up for anything. If somebody wanted to come in and help work on it long term, great. If you just wanted to turn up and contribute a little bit, just so you can say you've contributed, also good. And if you've got a particular burning feature that you just really want to see, that's cool too. The other way people can help actually, and this in some ways this is almost the most help, right? Is just by using it and showing
Okay.
people what they're building, right? Because the more people, like every now and then somebody, like I said this earlier, I think, but sometimes people will turn up and show you something that they built and you're like, oh, that's so inspiring. Now I want to do more and make sure that person can build all the things they want to build. And also other people see it and go, oh, that's cool. I want to try that too. And the more people who do that, the more contributors will naturally fall out of the group that are playing with it, right? So
Okay.
in many ways, just using it is
So
really
just
helpful.
build games, use games, and
Build stuff,
eventually.
report issues. There will be issues. Report the issues. We're very friendly.
Awesome. And so you told me that you prepared a small demo of the game that you built. So maybe it's the right time to have a look at this.
Sure, sure. So we'll have a go at that. Do I what
Maybe
shall
can
I
you maybe describe a little bit like what is it
Yeah.
like
Yeah,
or
let me do that quickly. We talked about like what shall I do? And it was like, can you do something in like 10 minutes? And I was trying to think of something we can do quickly with not too much context. So pre-pandemic, cast your mind back 4 years. I did a talk at a meetup, and for that I built a demo, and I built it in like 3 days, and it was called The Cursed Pirate. And I've kept that demo up to date for like the last 4 years with the various releases of Indigo, but the content hasn't changed at all. And the poor guy has been on his own for like 4 years. And I thought we would very quickly give him something to do at long last, right? So I'll
okay.
show you the demo. And I'm going to just talk a little bit about, as I go along, I'm just going to talk a little bit about like how Indigo gets built. In fact, maybe I should do that first, because what you're going to see is we're going to use the recently added physics support to add just a little bit, right? Nothing crazy.
Yeah.
But the physics support is really simple. Like it's not clever at all because I'm not a physicist. The way stuff gets built in Indigo is a very broad project, right? There's audio, there's graphics, there's animation, there's networking, there's IO, there's all sorts of stuff to do. And so I work on this philosophy of what I think of as embarrassing minimum viable products, right? Like
Mm.
what I do is I like build like the stupidest, ugliest thing that I should really be ashamed of, and then I push it out anyway, right? And one of two things happens. Either I get more use cases and I go, oh, I want to fix that because it's
Yeah.
not good enough and it's embarrassing. Or somebody else uses it and says, Dave, what is this? What have you done? It should be like this. And that's the best, right? When somebody looks at it and goes, this is terrible. Can I fix it for you?
It's
Yes, you
like a
can.
shame-driven development. Like you're
Shame-driven
so
development. Yes,
embarrassed.
exactly. Beautiful. Yeah, shame-driven development. I love it. Or we work on it together, or they supply some new library or functionality for it. Something like that. And some parts of Indigo, therefore, because it's such a broad thing and it's only really me doing the continuous development, some parts have had, hundreds of iterations to make them better. The core gets worked on constantly. The APIs get a lot of love. And then there's some parts which like can almost like embarrassing version one goes out and nobody cares, right?
Yeah.
And then it just gets left, and that's fine. I'm completely okay with that.
If it works, it
So
works.
if it works, it works. If it doesn't work, we'll fix it. So this version of the physics engine, there's been two releases, but the first version of this thing was made because I was trying to make Pong, like the little tennis game with the
Hmm.
white ball that moves, right? And I was halfway through that and I went, I might as well just turn this into a physics engine because it's basically very simple rigid body physics, right? So this is like the dumbest physics engine you can imagine, but it's still useful, right? And that's the beauty of an embarrassing MVP, the shame-driven development MVP is it's terrible but useful, right? And then
Yeah.
if we want it to be more useful, we can improve it. And there's another release coming soon. So let's have a look at the demo.
Yeah.
Uh, so
Awesome. Looking for it.
um, we just make sure this works. Okay. Can you see this? Okay. See my
Yeah,
screen?
I can see the screen.
Okay. So let me just run the thing first so we can remind ourselves what this looks like. This is the Cursed Pirate, and you can play this on the
Mm,
website.
it looks nice. I like this
So the
guy.
game, the graphics are entirely bought and paid for, and all that happens is he's found his treasure, but he's stuck on this piece of land. He can't get off, and every time he tries to leave, he just falls and comes back to the top. Right, and that was the entire demo of the meetup. And I want to give him something to do. So let's get out of there.
Did you
There's
do all
little
the graphic yourselves, or how
no,
did
no, no. I just bought them. If you want it, this is one of the roadblocks of game development, right? Like you could really get really upset about and obsessed with how good your graphics have to be. You can just go and buy some, right? For now, when you're building your little game, just go. They're cheap. It doesn't cost much. Don't let that be a blocker. Focus on the programming. We're programmers. We're here to have fun programming. Focus on the code.
Okay, so
Right?
it's a bit like a template for a website, for example,
Yeah,
right?
exactly. And once you if it works and you're happy with it, then you can invest the time in doing the assets. This was for a meetup demo, so I just bought some and I was very happy with
That's
this. With
amazing. I didn't know that.
there you go. So the first thing is I want to show you quickly.
So it just
Like,
is it built with
yeah,
Indigo or with Tyrian or both? This one?
this is all Indigo. This is all
It's
Indigo.
all Indigo.
Right. Yeah. So we have an Indigo game, and I'm only going to show you two parts of it. This uses the physics engine to do the work. And the way the physics engine works is it works like in parallel to the rest of your game. So you basically run the simulation, and each frame you say, "Hey, physics engine, where is my pirate? There's the pirate. Okay, I'll stick him on the screen then." Right. So
I see.
I'm going to show you quickly. Physics engine works with worlds and colliders. So it's very trivial to just render the colliders, which I'm going to do now. Here it's taking the world and saying present it, and this is what you should do with it. There's only two kinds of collider, a circle and a box, and they are
Okay, so
axis
essentially
aligned.
you just ask like, is these two objects have they collided or
Yeah,
where?
you can yeah. So
Oh,
here you
cool.
can see
Nice.
right.
Yeah,
So
yeah.
you can see the colliders, and all that happens is
Mm.
they collide and the pirate stops. Right,
Yeah.
boing boing boing, off the screen. Here I go. And there's a bit of logic that says if he goes too low, come
You
back.
go back to
Right.
the top. Yeah.
Yeah. So that's good. So what we're going to do is because the
Just like did you change the code like and you recompile it or the code?
all I did was I added this bit here, right?
Uh-huh.
So it was commented out. It was like
I'm
that, and
just
I've just
impressed because like I didn't notice you recompiling code or I mean it just was very fast. Like,
it's yeah, it's very fast. There you go, it's done.
amazing.
So okay, so what we're going to do is because the physics engine is like literally running in parallel. Here is the physics engine being set up, right? So I've got some platforms here, and this is my world, which is
Okay.
empty. I give it some settings, and there's some basic kind of like resistances and forces, and then we add the platforms, and then we add the pirate. What we're
Okay.
going to do is we're going to add the the treasure chest
Okay.
box, and you can tag your colliders. It doesn't have to be a string, but it's anything which has the appropriate type class will work. So I'm just going to use a string. It's easy. Um,
So
and
this
what
is
we
the
have to do
bounding
is
box. Okay. Yeah.
so there's two sort of levels of primitive. Indigo is a pixel art game engine. So most of the types are integers based, so like points, rectangles. It's all integer based because it's for pixels, right? Um, but here, when we're doing physics, what we have is I'm going to show you the space converters in a second. We work in doubles, right? Because we want higher precision when we're doing physics simulations, then we convert back to pixels at the end. I'm going to talk about what I'm doing here in just a moment. I just need to
Yeah,
get
sure.
some.
It's always difficult
Unfortunately,
to type and speak at the
I
same.
know, I know.
It's a
Unfortunately, I'm
bit
just
like,
not that
like
clever.
playing guitar and singing. I mean, I
Uh,
don't do either of them, but it's even more difficult.
right, so what we're doing here is zero.
I think it's with
So,
resistance. No,
no
restitution. What's
restitution. So
restitution?
yeah, I was going to tell you, I was going to talk about that. So what we have here is we have a box collider. This is an axis aligned engine. There's no rotation. It's just things banging into each other, right?
Okay, yeah.
So there's a box collider, tagged it as a chest. I've given it a basic starting position, and I've used this space converter thing, which I'm going to talk about in a second, to work out the right coordinates and sizes for that.
Hmm.
Restitution is how much energy the thing gets back when it bounces, right? So
Mm,
we want the chest to land with a thud. Right? We just want it to land
I
good,
see. Okay,
right?
so is
If
it
we
like so
wanted
like
it,
if a ball will have some restitution, right?
yeah, if you put it on restitution one, in theory, you have perfect bounce, and it boing, it elastically bounces back off again, right?
Okay, yeah, that makes sense.
Um, so I didn't come up with the terms; these are all from cleverer people than me. So one thing that's really important about game development is understanding spaces. So here I have a little helper, and its job is to convert from world space to screen space, right? And
Mm.
what that means is that when you, because you want to be modeling your game at the right abstraction level, right? And it makes no sense at all. So each box on the screen in this demo is 32 by 32 pixels. But does the model care about that? No, right? All it cares about is that there is a grid, right? And there is stuff in the grid, right? So each unit is one, right, in the model, and it has to be converted into pixels for rendering purposes. So this little thing, very simple, it just converts backwards and forwards between the two spaces.
It's a bit like
So
a
the
pipeline, like a first phase is your model in like a simple space, and then you have the
yeah,
representation, you draw it on the screen, right?
exactly. It's really important. We want the model to be as simple and descriptive as possible, and then all of the messy detail of how you draw it that happens later, right?
Yeah, it also means that your
Um,
tests are simpler, I guess, as well, if you need
much
to.
simpler, much simpler, yeah. And also save games, things like that are much simpler as well because you just literally save the model because it's a simple representation.
Oh yeah,
Off you
yeah,
go.
makes sense.
Okay, so let's get through this quite quickly. So now we have our new collider. I run this again, and there it is, right?
Mm. Oh, and you
And
push it. Yeah, nice.
when I push it, it falls off, but I want it to come back, right?
Ah,
Let's just do this quickly. So, um,
I'm
uh,
still amazed at the how fast does it recompile. Like,
I am on a shiny new Mac, I must say, but it is still
yeah, but I'm also on a shiny new Mac, and when I recompile my code, it doesn't take.
modify my tag. So here, what I'm going to so here what I'm going to do is I'm going to very quickly uh, modify the behavior. So let me actually, I can't really type and talk at the same time, so I'm going to crack on with this.
Yeah, go ahead.
Um, I feel like I should have possibly done this earlier, but never mind.
So does this modify by tag, does it like look for the chest inside the
Yeah,
world? Yeah,
yeah,
okay.
exactly.
So it's a bit like a selector.
Yeah, yeah, exactly. So C dot with position. So what we're really saying here is, hey, simulation, never mind where you think that thing is. I've decided that I need it over here now
Yeah.
because something's happened, right? Um, okay, so it's a very simple. Oh dear, what have I done? Oh yeah, right. Yeah, need the other case statement.
Okay.
Do, do, do,
Yeah,
do,
it's
do,
like,
do,
oh,
do.
so you say like if it's below the map, then
Yeah.
okay.
So the map height is just in units. There's like 12,
Yeah.
and then if it's too low, come back to the top of the screen. So that run it
And I guess
again.
you have the same function for the pirate somewhere.
Exactly. Yeah, it's just a bit below. So push it off the screen. Oh, it landed on my head.
Oh.
Okay. Okay. There it
And
is.
the in terms of like the when it falls down, it feels like it comes back slightly to the right. Why is that?
I start. No, that's just where I started it from. That's all. I think I did, unless I messed up my coordinates a little bit. Yeah. So it starts. Oh yeah, you're right. It starts slightly to the left. There you
Yeah, because
go.
it comes back like a
Pretty much there, same place. Yeah.
yeah. Oh, I
Sorry,
see.
I put it over there on purpose. It's just so it's out of the way.
Okay.
Okay, so let's sort out this treasure chest then. So the first thing is, at the moment, the treasure chest is part of a separate graphic. It's over here on the
Yeah.
right-hand side. So
Hmm.
we need to change that so it's not there anymore.
Okay, so you want to associate the graphic of the treasure chest to the box you just created, right?
Yeah, exactly. So the minute, so I'm going to change it so it's just, so we just have the spilt coins on the floor, right?
Hmm.
And the chest has gone. And then what we need is draw chest function. So, so we're going to draw the chest. Um, chest provider, which is I'm regretting not pre-preparing a little bit of this. Never mind.
Is it a new function?
Yeah. Oh, sorry. Yeah,
So
you're
you
right.
might need a def. Yeah.
You're quite right. Thank you. This is what you get for rushing on the job.
No, but it's very difficult to live code. I've done it a bit, and it requires hundreds and hundreds of repetitions.
So what we want to do is we want to manufacture an asset, right, or a thing that you can render, which is the base type in Indigo is a um, is a scene node, right? But there's different kinds of entities that you can manufacture position. So we need to work out what the position is going to be, right? That we need to render this thing out. It's got to be based on the collider, right? So the first thing we need is some bounds, because the way the graphic is set up, if I can show you this thing here,
Mm-hmm.
right? I've set it up so that such that there's a thing called a reference point. And the reference point is sitting right at the bottom on the floor, right? And
Okay.
so it's underneath the lock and it's at the bottom of the graphic, right? So we need to work out how to do that. So we need our space converters. Um, oops, yeah, world to screen, convert. So we take the chess collider, bounding box, and that's going to give us a rectangle, right?
Okay.
Which we can just use. And then the position is going to be a point, and it's going to be the on-screen bounds center. So we want the middle, and the on-screen. Oh, sorry, bounds, not on-screen bounds. My bad. Bottom.
Mm-hmm.
Okay. So now we need to call this thing from somewhere. It's going to be important. Um, foreground. So we use this type called a batch, and batch is essentially a list-like type, but it's much quicker. It's more performant in terms of
Optimized. Okay.
yeah, it uses a Scala.js array underneath, which is super fast. So we're going to need our collider in scope. Collider box. Oops. Uh, do, 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 do. And we're going to need our space converters again. Right, we'll just pass them through. Now we should have some errors here. This is fine. So what we need to do is just copy that. So here we're reaching into the model, saying,
Give me the chest.
give me the chest, chest,
Mm-hmm. Yeah, makes
um,
sense.
and what am I going to do with that? I'm going to,
Is it
yeah,
that you need to
of
pass it to
course,
the draw
yes,
function? Yeah.
absolutely, that's it. Yeah,
There was, yeah, space.
space converters, and we don't quite have those yet. Oh yeah, but it's view model, not space converters. Okay, because these things live on the view model. And let's see what we've got. Hopefully I haven't messed anything up. Yay! Look at
Wow,
that.
nice.
And for the first time in 4 years, the pirate has something to do.
I'm impressed. And you did it the first time around, that first recording. Whoa,
Oh,
and
we can get rid of
I'm
the.
really impressed.
We just quickly get rid of those as well. It's for fun. There we go.
Pretty cool.
Complete.
Congratulations. It looks amazing. I really like it.
New feature added. Right. I'll stop there. Cool.
Well,
Lovely.
thank you, Dave, very much. It was very amazing. I really like this demo and generally talking to you. It was a real pleasure. So very thank you
It's
for
been
coming
great
here.
fun.
Nice. And guys, just like a quick shout out to our sponsors, Scala Jobs. So if you're looking for a job or if you're hiring, don't hesitate to reach out to me or to check out our platform, scalajobs.com. We are really like a team of experts, of developers and recruiters to help you to fill like any gap that you need. And we worked with Dave in the past, and I think we had a nice working relationship.
Yeah. Right.
Awesome. So see you guys.
Right. Thank you. Bye bye.